Right, so here I have the initial list of the head wall features. There's some different considerations that we want to take with these head wall features. Again, we're thinking of graphical versus hydraulic differences. So graphically, this is going to be like the length of the head wall, the conduit shape, whether that be circular, ellipse, or arch, the size it's coming into it, what material that's going to be, if it needs to be modeled with or without a grate, and then those construction class elements that I pointed out. Hydraulically, we aren't doing as much with these head walls. The only thing we can predefine is going to be an inlet and outlet coefficient if we're going to be analyzing any culverts. But I want to provide some options for you when you're building out these lists if you want to try to reduce the number of cells that have to be created, or maybe not the number of cells, but maybe the number of feature definitions that you have. So I do recommend that you create one per size, as I've done here. But then in some cases, particularly like box culverts, you'll have a lot of different ways that you can set up a head wall. So you could have different wing wall configurations, they could be placed at different skews, and you could quickly add up a very large number of cells that need to be modeled and then corresponding feature definitions. So I'm going to give you some options here. One option is, of course, we can always group these into sizes. So we could have a size ranges and one feature per size range, and then just use the most common size as the cell that's going to represent it. Probably the preferred option is going to be one cell per size. But I want to talk about parametric cells a little bit. All right, so parametric cells are not currently supported for drainage and utilities features. However, I want to provide this option to you to try to reduce the number of feature definitions that you might run into for head walls. Right, so over on the right, I have an image of the place parametric cell window. So the idea here is that we create many different variations as part of the same cell model. So when you go and place that parametric cell, you can choose the variation, the size that you need, and then that is going to place the cell that matches that variation with the different variables. Now, although parametric cells are not supported for drainage and utility features, we can still place them inside of the models. So the idea here is that we're going to create a generic head wall feature definition for each type of head wall. And that's just going to place generic nodes in plan in 3D, and we can still use those as we would normally to do design. And then after the design and analysis is complete, then you can manually place the chosen variation of a parametric cell in the plan, 3D, and profile models. Now, you need to keep in mind here that this is going to mean that you will manually update the cell placement in these design models if you have any design changes. But doing this is going to greatly reduce the amount of feature definitions you need for head walls while still allowing you to have the correct graphical representation. All right, to be clear, in most cases, you are going to want to create a separate head wall feature definition for each size and type. But if you do have a situation where you have many possible setups of these wing walls configuration, then using a parametric cell might be beneficial to you.